Continue on from where we were last time. Geometry is what the acorn said when he grew up. G on the tree. Okay. Fun Sock Friday, the 14th of February, 2020. Okay. Because I know what I'm doing this year. I got 20/20 vision. Okay. I'm getting married in 4 months and 15 days, in case you're wondering. Okay. SWA students will be able to finish 6.4, which is solving ratios and proportions. Okay. We started out with that, and now we're going to continue that and finish that. Okay. So we started off by saying, what's a ratio? And we said a ratio is a comparison of two or more quantities, aka numbers of things. Okay? We said there are 3 ways to represent a ratio: fraction, words, and then colon. And we went through and made ratios and simplified them. Then we said, okay, an extended ratio is a more specific type of ratio. This has to be 3 or more. Ratios could be 2 or more, but extended ratio is more specific. It has to be 3 or more. And we just write it A to B to C. This was
right after what is your proportion?
No, right before. Right now we're recapping, not capping, but recapping. Right before what is a proportion. Okay. So then we went over these extended ratios. We applied it to complementary angles, supplementary angles. Because last time we had Nolan and Colton complimenting each other, reading the complementary angles poster. Okay. And then we applied them to angles in a triangle, the sides of a triangle for the perimeter, and then we talked about what is a proportion. This is where we left off. So we said a proportion is when we take an equation and it states 2 ratios are equal. So we take 2 ratios and we put an equal sign between them. We get 2 ratios, we put an equal sign between them. We're saying these ratios are equal. And we write a proportion as A to B is equal to C over D. So A to B is a proportion, C to D is a proportion, and we state that they're equal. Okay? Then when I went over, and this was the very last thing we went over, I said, hey, I'm just going to go over this briefly, and then we're going to recap it next time. So this is us recapping next time. So we had A over B is equal to C over D. And I said, okay, what would I do if I wanted to get rid of our variables in our denominator? So we said, okay, well, we multiply both sides by B over 1. Okay, so we said those B simplify. And then we have A is equal to B times C. Because C times B, B times C, same thing, just alphabetical, over D. I said, okay, well now let's try and get rid of that D in the denominator. So we said, okay, let's multiply by D over 1 on both sides. We said these D's will simplify out to 1, so it left us with BC, and D times A is A times D. So now, what ended up happening was we had A times D equals B times C. We have nothing in our denominator anymore. We have nothing in our denominator. The bottom part of a fraction, so you don't have to write a fraction mark because you don't have the bottom part anymore because it's just a 1. And now, A and D, the D switched sides, didn't it? The D switched sides from where it was originally, and the B also switched sides from where it was originally, okay? But the A and C stayed where they were, okay?
This might just be me forgetting, but can A over B equal A over B?
Yeah, that's just like the same thing as saying 3 equals 3, though.
Well, yeah, but like...
We wouldn't use that as a proportion. Yeah. Because it's just the same ratio. It's like saying 3 equals 3.
Yes.
Yeah.
Okay, so what if you're doing it like with numbers and then like, but like, I kind of like moved ahead and I'm confused.
Yeah. So.
Because like, how do you still like multiply even if the numbers with an X?
Yeah. We'll talk about that. Okay. Yeah. So, what we call this process here is we're going to call it cross multiplying. We're going to call it cross multiplying. And so we're going to call this cross multiplying, and we can end up shortening the process. Because what would happen, no matter what we do with this, because if I were to go through and do the same example, but I just fill in numbers instead of A, B, C, and D, like let's say I do 4 over 6 is equal to, 3, 8 over, actually let's do 8 over 12. Okay? 8 over 12,
Ooh, yeah.
okay? So what I could do here with 4 over 6 is equal to 8 over 12, you guys don't have to write this, okay, is I could cross multiply again. So I could end up doing, we took this D, it ends up multiplying with the A. We take this B, and it ends up multiplying with the C, right? So you take this 12, and it's going to end up multiplying with this 4 over here. And I'm going to get 48. This 12 times 4 is 48. And this 6 is going to end up multiplying with this 8, just like the B down here ended up multiplying with the C up here. So the 6 is going to multiply with 8 and get 48. Does 48 equal 48? Yeah, so that's true. So that's why it works out. And if we had started off and just done 4 over 6 is equal to 8 over 12, and we had simplified, 4 over 6, what goes into both 4 and 6? 2, and it becomes 2 over 3, right? What goes into both 8 and 12?
4.
or and it becomes 2/3. So either way, they end up equaling each other. So it's just saying that the proportions are still true and they're still accurate.
So can we do it either way? Like, can we do the simplifying and
Yes, what we'll end up doing though is we'll end up actually having it to where we'll end up cross multiplying really every time. But this is just saying that this is the same thing as we see that these ratios are equal here. We see that these ratios 4, 6, and 8, 12, they're actually both the same thing. They're both 2/3. So this process of cross multiplying is mathematically accurate because we still have these two sides equal to each other. We didn't unbalance anything. It's not like we have 45 and 48 to where we unbalance them and they're not equal anymore. They're still equal. So we're saying A times D is equal to B times C is mathematically okay because it would be the same thing as if we had just simplified them like we did here. But we just can't simplify A over B because we don't know the numbers. So we call this process, the shortcut that I did, this 12 times 4, 6 times 8, without writing all this extra stuff on the sides, we call that the cross product property. So for any proportion, this A over B is equal to C over D, we can have that could be A times D is equal to B times C. That we can cross multiply, so to speak. We can cross multiply, so to speak. Okay? When it says by multiplying cross, it's like diagonal. Okay? Now we're going to use this here, solve each proportion using the cross product property, because here we have actual numbers. We have 4, 6, 8, and 12. There's nothing that we actually needed to solve. But here, 4 over x is equal to 2 over 7. Do we know all the numbers? No. We need to, so we can figure out what x would equal for this to be an accurate proportion. There's only one number it could possibly equal for this to be an accurate proportion. So what we can do is we can do this cross product property where we can do cross multiplication. So I can do 4 times 7. And what is 4 times 7? 28. And then I can do x times 2, which is 2x. And see how we ended up kind of getting a crossing happening there? That's part of why it's called cross product. Because it's cross multiplying. Product means multiplying. So we end up getting 28 is equal to 2 times x. Any questions on how we got 28 equals 2x? If you don't get that part, we need to clarify that now before we continue. Otherwise, none of this is going to make sense. Yes?
Are we gonna find x?
We will find x. I'm asking before we continue, does anyone need a clarification on how we got 28 equals 2x? Because if you don't get that, you're going to be lost the rest of this note section right now.
If there's an equal sign, cross.
Yes. If we have two fractions equal, aka proportion, two fractions equal, we're going to cross multiply. Okay? So now, can we solve this equation? 28 equals 2x?
Yep.
Yeah, we might have had trouble solving this earlier, but this we know we can solve. How do we solve it?
X equals 14.
Divide by 2, and x is 14. Now, does it matter if we have 14 equals x or x equals 14? No. Okay? So it doesn't matter which one we have. So we solve for x. Now, if I were to have gone back, and I can check now. I can check my answer if I wanted to. You don't have to. I never make you check, but you could. So if I were to go back and check here, and I try plugging in at 4 over 14, then I'm going to ask, does that equal 2 over 7? 4 over 14 equals 2 over 7. Well, can 4 and 14 simplify?
Yes.
To what?
2 over 7.
2 over 7. So does 2 over 7 equal 2 over 7? Yeah, it does check out, so it does work. That is the proper number there. It wouldn't have worked if it was 15, because 4 over 15 wouldn't simplify. And that's not the same thing as 2 over 7. Okay? It wouldn't have worked out if it was 16, because then it'd be 2 over 8. Okay, so it had to be 14 for it to work. Okay? Questions on that? Okay, I want you guys to see if you can try number 12 here. I want you guys to see if you can try number 12 here. Okay? And when you get it, or when you have questions, okay? When you get it, or when you're stuck in that question, I want you to raise your hand. Okay? I got you try number 12 here. When you get it, or have a question, I want you to raise your hand. Okay, and we end up getting a decimal here. So you'll probably want a calculator. Excuse me. I'm okay with us having a decimal here. I'm actually okay with us having a decimal here. So you're probably gonna want to get a decimal here. Okay. So if you want a calculator, raise your hand, I'll bring you one calculator. If you want a calculator, raise your hand, I'll bring you one. Okay, so if you want a calculator, raise your hand, I'll bring you one. Okay. Okay, what's the last two? I'm gonna leave there anyway right now. I'm ahead. Oh, okay. Maybe raise your hand first.
I have a question.
Go.
What do we need to? What do we need to?
You do 19 times 12. Oh, you do 19 times 12, right? So what then you do 10 times x. Yep.
Yeah.
Okay, go. How you return? Alright, so this one we end up having is we do 19 times 12, which you said is 128 or 228, excuse me. And then 10 times x is 10x. So now we divide by 10. And this one you might not need a calculator because dividing by 10, we can use the rule of decimals, or we can move the decimal over, and get 22.8 is equal to x. If you use a calculator, nothing wrong with that either. Questions on that one? Now if you go back in and plug this in, but it wouldn't be as clean to plug this one in, would it? Because if we go back and plug this one in, and we do 19 over 10, well that doesn't simplify. And if we do 22.8 over 12, that probably wouldn't simplify very well either. But a fraction is really what type of problem? Division. So we could do 19 divided by 10, get whatever decimal that is. Okay, Sam, do you want to do 19 divided by 10 real quick? Show me the decimal. 1.9. And then do you want to do 22.8 divided by 12 as well? I'll pick on you. So they end up being the same, which means they check out as well. So this one also works. Okay? So you can always go back and check, which is really handy because you know if you got it right or wrong. Questions on that? Okay. So now when we do number 13, for example, and we cross multiply here, because once again, fractions equal to fraction. Here on the left side, we're going to do 19 times this whole thing. You don't just do 19 times x, you don't just do 19 times negative 1, you do 19 times the whole thing. So sometimes what can be helpful is to write out 19 times x minus 1 like this. Sometimes that can be helpful to write out. You don't have to, but sometimes that's very helpful. Okay? And then we can do 6 times 13, which is going to be 78. Okay? And what do we need to do with this 19 and this x minus 1? Should be, right? So we can have 19x minus 19. So 19x minus 19 equals 78. And even though this is one more step than we had before, are we still able to solve this? Yeah, we still are, okay? So go ahead and finish solving that one. When you have it, or have questions, raise your hand. Go ahead and finish solving that one. When you have it, or have questions, raise your hand. Nope. Okay, yep. And you can round to the nearest tenth. You can round to the nearest tenth. How many decimal places is that? Nope. One. Because it takes 10 of those to make a whole, so it's called the tenth. Okay? I'm saying, yeah, I know.
Is it gonna be a decimal?
Yeah. I want you to round it nearest 10, okay? Yeah, you don't have to plug that in. You can use the word.
Okay, I got it.
That's gonna change it. Very good.
Oh, Mr. Cosgrove. That's correct. You get 270.
Yeah.
How do you get 270?
Is the equation supposed to be 5x plus 4? This is Oswald. Is the equation supposed to be 5x plus 4?
Guess if you multiply it like all together.
Oh. It's taking long enough. Yeah, forever.
So let's talk about the rest of 13 up here. So to get x by itself on 13, we have to add 19 to both sides. We have to add 19 to move this away. It's already negatives, we add it to both sides of the equation. So we have 19x is equal to, now 78 plus 19 is going to be 97. Now we divide by 19, and we end up getting x to be equal to 5.10, okay, and it keeps going. But we can just call it 5.1 because we can just go to the nearest tenth here. Now, if you want to, you can go back and check by saying 5.1 minus 1 divided by 6, and does that equal 13 over 9? You don't have to, though. You can if you would like to. Did you get signed?
Yes.
Mrs. Aswell? Did you sign? Okay, sorry, I didn't see that. Sorry, my bad. Did you pass it through Grace? Oh, okay, gotcha. I thought you just took Grace's and all okay. I gotcha. That makes more sense. Sorry, I got the tail end. Okay. Questions on 13 here. Questions on 13 here, how we got that. Okay, so then if we go on to 14, does anyone actually want to come and do 14 up here? Anyone want to come and do 14 up here? Go ahead, Mackenzie. You can bring up your paper if you'd like. Okay, and I'll let you pick your color if you'd like to.
Have you tried one of Miss Party's famous homemade pretzels? She hasn't given you any? That's really surprising.
No, she probably will.
I love. She's on my bag.
What?
Did you not? Let me go get mine.
I did.
That wasn't one of the prizes, was it?
What did you get for your prize?
I got like the fruit snacks or the hearts.
Yeah.
They're really good.
I heard it, but that was like not.
Yes.
Sorry, it's better than
I
that.
did the non-food
It was a nice little
option.
surprise. Yeah.
Yeah. Nice, but I figured it would be better.
Should've done the non-food option, like me.
Mm.
Beads.
I don't.
Can you win twice?
I don't go kickboxing so that I can eat more than crab.
Exactly.
On this one.
Girl power, girls. Yeah.
To lose 7 pounds just by eating crab.
Yeah.
Okay. Mackenzie, can you explain what you did?
For all my inches.
Can you explain what you did?
Oh.
And actually, we should round to 60.6. Yeah, that's what you had in your calculator. You had it.
Ooh.
Did you
I wanna see their reaction.
Yeah, we're having food.
You told me your phone? I don't want it.
Rodriguez.
You wanna do it?
She just was like, you guys can food on.
So Mackenzie's gonna explain what she did here real quick.
Woo!
Good stuff, got 60 points.
Yeah.
Good work. Any questions on that one?
I just had kind of a flashback.
Okay.
Have you ever watched Blue's
I watch that all the time.
That was my thing
Queen
too.
of
I know.
Scotland.
Until they change
Clues?
the guy.
Blue's Clues.
Wait,
Like the guy
Yeah.
that's like, we just got a land.
Yeah,
You know
yeah.
what I'm talking about? Yeah.
yeah, good old Steve.
Wonder who it's from.
Yeah,
Who
he's the
knows
best.
from her places? She got like cancer.
That one was fun.
Yeah, it was big sad.
Oh,
I
he
didn't know
died?
that.
Wait,
What if he died? He got cancer, so they had to replace him on Blue's Clues.
Hey, I want you guys to try 15 and 16. I want you guys to try 15 and 16. When you have 15 or 16, when you have 15 and 16, I want you to raise your hand, or when you have questions, I want you to raise your hand. Okay, 15 and 16,
Can we
let's
move
try
on to
these. When you
17?
have them or have questions, raise your hand. What?
Can we move on to 17 and 18?
Sure.
can you give me a calculator really quick, like speed quick?
Wait,
Get it, look at it. You did kickboxing today.
Or, sorry, yours up.
Wait, how early in the morning do you get up to do kickboxing?
Yep, and that.
Do I get up?
Yeah.
I have to be there at 5:45, and I get up now.
So we need to set up at 9. Yeah, that's good.
My alarm goes off at 5, but I don't get out of it.
Yeah. That's
So I
me.
brush my teeth, put my clothes on.
This morning?
Go.
This morning I got up at 5:54. I got ready for 5 minutes. Because I slept, or no, not 5, 7. 7:54.
I miss those days when I get up at 7.
Yep, yep, because you did this times this, so you crossed them. So we can do 10 times 9.
Can I run it?
Of course you can, if you want to. So you can just do the dot, you don't want to. Equals, yep, times, and we want to put the 2x minus 9 in parentheses.
Where's that?
Don't let her in.
What? I thought you were
Oh, I think you said no. I was like, oh, okay. Let me keep helping.
I feel bad.
Mr. Council.
Have you ever had to do the thing where you have to point your toes and go up higher, cross each leg?
Boy.
And then you go down? Yes, hear me, I'll cross your legs and like point your toes. And the face is always going to go up. Yeah. Did you just do an exercise on the floor?
I did.
Oh.
Did you miss it? Yeah.
What do you have to do?
I have a little circle around my legs with a plastic band over it. Put it on the back of it up here, and the back of it up here.
Wait, how old are you doing that?
She gets up at 5.
And my alarm goes on at 5, but I don't get up at 5, and I have to be there.
Ooh.
Operations. Repeated multiplication. So we do 20 what with 2x?
Are they ready?
20 times 2x.
What if it's a like ongoing thing?
And then 20 times 9, because we had 19 times x.
Are you
And 19 times 1. Negative 9.
you like it? Yeah.
We're going to do 20 times 2x and 20 times negative 9.
So I would do 40 right here and then I would do 20 times 30. So I don't know what who
I could have taken
pictures of that one for the grabs. I was like 6 Yeah. Oh, my God.
Why didn't you?
I got -8. Like classic. Do you play volleyball every night? You're so sore. So I just whole thing. Oh.
Can I have you come over here while I'm holding the kitchen?
Okay, wait. I guess. Like, actually,
With 0 caps.
What's a better choice?
okay.
What time do we go to lunch?
If I have to do
Like-
30, I mean 12:30,
Just like
sorry. I know, I swear though.
Are we gonna start 6:45?
Should I do like the first six?
Ah, shucks. I'd rather do homework.
So I can't do 2x was 20 times 9. Like that. Yeah. It's gonna stretch your 180.
No, 180.
Yep, just go ahead.
All exercising, Mr. Possible.
Okay, no guys, you guys gotta go like this. You gotta Grace,
No, Grace, sit back down.
and we usually Gracie, like this, put your hand like that, and then go. That's good like. No, yeah, it don't feel right. My like whole back goes.
What did we do here? We got something else.
I even know.
Did we do the X? Because, hey, let's go ahead and add 380.
40x, you would minus
That's why.
480. Yeah.
Comes out to. Do I go into the next one? Yeah, I'm at 2 point.
I disagree with you.
Oh, sorry, I was in the wrong one, that's fine.
Okay.
Voila!
Imagine looking at Am I supposed to do that? What the heck? That was confusing. No. But I had to do that.
Negative 33.
Correct. Yes.
Did I do it wrong? Oh.
I haven't seen this.
Oh, we're supposed to keep going? Are we supposed to keep going?
You just kind of look at it, telling you guys gotta get up every morning and say, I got my one thing I'm grateful for and concentrate on that.
We're
Trust me,
doing
I'm not
just
happy
this.
yesterday. I was kind of irritated last night.
And then I got mad.
Okay.
And then here I am.
Okay.
I'm at the hospital.
So on 15 here, let's talk about 15 up here. Okay. Let's talk about 15 up here. Okay. So we're gonna cross multiply. We have 10 times 9, which is 90. We have 20 times all of this, so 20 times 2x minus 9.
Why were hitboxing?
So 90 is equal to, distribute the 20, 40x, side combos your done, please. 20 times negative 9 is negative 380. So we have 90 equals 40x minus 380. We want to get rid of that 3. We want to get x by itself. Our goal is to get x by itself. So to do that, we're going to move away the normal number away and put the normal numbers all on the other side by adding 380. So we're going to get 470 is equal to 40x 470 is equal to 40x, and negative 380 plus 380 at 0, so we only have 40x on this side. Now that we just have a number multiplying with x, we can divide by 40 on both sides, because 40x divided by 40 is just our x, and then 47 divided by 40 rounds to 6.8. It's 6.75, which rounds to 6.8. Sorry, Sam asked me. Sam asked if I would write this like this. So we could also color 8 like that, I guess, if you really wanted to be weird. That's just really weird. Sam just asked if I would do that. Okay? Mrs. Haswell.
I got the right answer, but
I didn't use.
Mine was at 6.8.
but I
That's
didn't get
470.
Did I say 470?
I got 270.
Yeah, it should be 270 because this should be what? Not 380, but it should be.
You're not even doing your math. You're just going off your notes.
No, I have 180 here.
No,
Right.
4 or whatever.
How did you get 180?
This should be.
Or how did you get 380 and I got 382?
So must have multiplied wrong. Must have typed something in the calculator because I was like going off what when we used the 3. I'm like, oh yeah. So it should be 180.
You must have been
Should be
helping me
180.
get the wrong answer.
180.
Because I was trying to
So it should
redo
be
this.
270, which would then be 6.8.
You should have done your whole math. Then you would have caught yourself during the problem and we wouldn't have to
Would've.
tell you.
I did my math on here once.
Yeah, right.
You want to see my handwriting?
No, I
It's-
can't read it anyway.
It's very obvious it's my handwriting though.
Oh, we know when we see something it's like
That
that third
next
grader
one,
is
please,
that
Mr.
Mr. Parcel.
Okay, you want to do this next one?
Yes.
Go ahead.
Wait, make sure my answer's right first.
Oh, okay.
Is it 220? And if it's not right, then I'm
Yes.
That's right. Okay. Okay, y'all. Okay. So let's Sam in first.
about to miss my lesson.
Okay. So first, you cross multiply. So you take 15,
Sometimes it doesn't.
15, and multiply by 12, which is 180. And then do 18 times 3x plus 4. So 18 times 3 is 54. This is really off. I'm sorry. 54, and then 18 times 4 is 72. So you add 72, and then you subtract 72. Subtract 72 from both sides, and then you get 108 equals 54x. And then you want the x alone, right? The x alone. So then you divide each side by 54, and you get x equals dose. Thank you.
Very good, Gracie. Slap on the back. Very well explained too. Okay. Must have had a good algebra teacher.
Debatable, but
Okay, that's fair.
Only
So-
love us.
So,
you were right.
questions on number 16. Question on number 16 here. So, hey, on 17 here, we can do the same thing. What might look intimidating on number 17? The fact that there's two different x's, right? That might look intimidating here. But if we go through and cross multiply this like we have been, we'll find that we're going to have 18 times the quantity of x minus 20 is equal to 3. Goodness. This is not cooperating. Okay. 3 times the quantity of x minus 11. So that would be our first step, is just to set up the fact that we are going to distribute this through our cross multiplication. Then as we go through and distribute, okay, it's going to make Jillian happier if I put that down. Okay, so I'm going to do 18 times x, which is 18x. 18 times negative 20, which is negative 360, is equal to 3 times x, which is 3x, and 3 times negative 11, which is negative 33. So we just distribute on both sides now. So instead of distributing on one side like we did earlier, we distribute on both sides now. We've had problems like this back in algebra 1 as
Okay,
well.
wait.
Okay.
Okay. never mind.
So from
I was
here,
trying to process
we
something.
want to get all of our x's together on one side. Would we rather move the 18x by subtraction or move the 3x by subtraction?
3.
Probably move the 3x. So I'm gonna subtract 3x from both sides, excuse me. 18x minus 3x is 15x minus 360. Man, right? It's like for some reason lately, it's like drags actually. Like when I pick it up, it doesn't register that I pick it up.
Yeah, that's happening to
But-
me too.
So is equal to 15x minus 360 is equal to, well, 3x minus itself is 0. We can verify that gets rid of it from this side. Minus 33, or negative 33. So now, are we at the same spot we've been in on these other equations?
Yep.
Yeah, we're at where we were up here and here. So now we have to move the constant, that's what we call the number without the variable, the constant, because it's constantly that number, it doesn't change. It's not able to vary like a variable. It's variable, able to vary. So we move this 360 away from that by adding to both sides. Because negative 360 plus 360 is 0. So now we have 15x is equal to, well, this, different sign, so we subtract, keep the sign of the bigger number. 360 is bigger, so we're going to keep it positive. And 360
327.
minus 33 is in fact 327.
I did that right here.
Nice. Okay? So now we're at the point where we divide both sides by 15. We're going to divide both sides by 15, okay? And then we can trust our handy dandy calculator to get us from here. And if you don't want to trust the handy dandy calculator, you could do it off to the side, okay? But to make Jillian happy, I'll do it off the side, I'll do my own math, okay? I'm just giving you crap just so you know, okay? So 15 doesn't go into 3, but it does go into 32 twice. And 2 times 15 is 30. Subtract, we get 2, so we carry down the 7. 15 goes into 27 only once, which would be 15. Subtract, we get 12. Now to figure out what the decimal is. Okay, well, does 15 go into 120? Yes. Okay, the question is how many times? Okay, I'm going to go with 80. Okay, 8 times 15 is actually going to be exactly 120. And so we end up getting 21.8. So we don't have to worry about rounding here. Go to 10. And we could always go back and check our answer by plugging it into both x's.
I'm
and
so
seeing if
glad
they
that you
equal.
let us use calculators. Thank you.
Yeah.
Do a lot of work.
Yeah, I don't let you guys. I don't let
doesn't.
in geometry.
Yeah.
You guys get it. I don't let my algebra 1 students use them, as you know. So all of algebra 1 I don't let you.
But that's
Every
like all of
geometry related.
that's just like all math instead of like formulas like this.
I make you guys do this stuff in algebra 1 without calculators. These are building the math skills still. Questions on number 17 though. Okay.
Let's skip number 18.
We are actually gonna skip number 18, but guys, it's the same kind of problem as 17. Cross multiply.
What is the answer?
The answer ends up being 8.5. I looked at my sheet for that one. because I did not solve it.
Good.
But it is 8.5. So we got McKinsey.
Yeah.
Okay, good. That means it's right.
Are we in the next section too?
Okay. No, I'm actually not gonna do 6.5.
We're gonna do 19 and 20.
We're gonna do 19 and 20. And these are a different type. These are gonna end up being different. Okay. Now we notice a subtle difference between 17 and 18 compared to 19 and 20. What's our subtle difference?
The same x's.
Okay.
Like the
What do you-
problems I have x's in it were cross multiplied.
Okay. So when we cross multiply here, we're gonna cross multiply our x's together. Okay? Because here, instead of our x's both being on the top or the bottom like they were on 17, 18, they're going to be one on the top and one on the bottom. So what's going to happen here is we cross multiply because we have two fractions equal. We're going to have 5 times 27, and we're going to say that's 135. And then we're going to have here x plus 5 times the quantity of x minus 1. So we're going to have x plus 5 times x minus 1. Does anybody remember how we multiply two binomials? Going back to algebra 1, how do we multiply those? FOIL, we call it FOIL. It stands for first, outsides, insides, last.
I hate
FOIL stands for first, outsides, insides, last. So we do the first part of each of these parentheses. So we do x times x. So I'm first going to write the 135 equals. X times x is what?
2x.
Not 2x. X plus x is 2x. X squared.
Oh my god.
Squared means you're multiplying two of them together. So x times x is x squared, two x's being multiplied together. Then we do our outsides. X is on the outside on the left. Negative 1's on the outside on the right. So x times negative 1 is negative x, or negative 1x. Then we go through and we do our insides. First, outsides, insides. 5's on the inside and x on the inside. 5 times x is 5x. Then we do our last. 5 times negative 1. Last in the first parenthesis, last in the second parenthesis. 5 times negative 1 is negative 5. Okay? I was actually just teaching this in Algebra 1 yesterday.
Is that 5x?
No, this is 5x. My pen kind of went weird. So the only x squared is the first x squared.
Okay, so you can't, I'm just like stating something and you're correct or not. So, x cannot combine with x squared because they're not the same number.
Correct, yep.
Okay.
Good. We can only combine like terms, so we can't combine x squared and this negative x, because even though it's the same variable, they're not the same power. But what can we combine?
Negative 1x and 5x.
Yeah, negative x and 5x, okay, which ends up being what? Plus 4x. If you don't change the exponent there, minus 5. Okay? Now, in order to solve this one, we have to put our algebra 1 cap back on. We have to put our algebra 1 cap back on. Pretty hardcore, okay? In order to solve this problem, we're going to need a factor, okay? Hope you guys remember that at least factoring was a thing. If you don't remember how to factor, hope you guys remember factoring is a thing, okay? We're going to discuss how to factor here. So in order for this to work, in order for factoring to work, we need it to equal 0. We need it to equal 0. So that means we need this number to be 0. So how do we make 135 0? Subtract 135. And if we subtract it from this side, we have to do it from this side as well.
Okay, so you don't have to do like the plus 5 stuff?
Nope. We need to move this negative 135 over because we need it equal to 0 in this case. Yep. So we have x squared plus 4x minus 140. And now this is where factoring comes in. Factoring means we're going to try and get it down to where we have two parentheses being multiplied with each other. Similar to kind of how it looked at the start, but what's going to be different is going to be equal to 0 now, which is significantly going to change what we can do at the end. So when I factor, there's lots of different methods you can learn to factor. When I factor, what I like to do is called the x method. So I draw an x, big enough to where I can write numbers on the top, the bottom, the left, and the right. At the top, I put what I call a times c, and at the bottom, we put b. This comes from the form of what this is called a quadratic equation, where this is ax squared plus bx plus c. So the a is whatever's with x squared, the b is the coefficient with x, and c is the number by itself. So here, what is our a?
X squared.
What's with the x squared though? We don't see anything. What is it? 1. So here our a is 1. What's our b here? 4. And what's our c? Negative 140. So those are our a, b, and c. So in the what was that? Negative 140. Okay.
Oh, that's so
Okay, we have to take this negative with it. So now, at the top of our x, I say I put a times c. So 1 times negative 140. What is that?
Negative 140.
My pen went weird. It's 1.
It looks
So-
like the
A times c, 1 times negative 140 is negative 140. And then I'm going to put whatever the b is at the bottom. So in this case, what I'm putting at the bottom? 4. And what we're doing is we're going to fill in this puzzle, so to speak. It's kind of like a puzzle that we need to fill in. We need to figure out what the sides are. Now we need to figure out two numbers that can go here. We're going to put one number on the left, one number on the right, to where they multiply to the top. These two numbers will multiply to get negative 140, but they will add to get to the bottom, 4. So you figure out what two numbers can this work with. So if they're going to multiply to a negative number, what do we know about the two numbers? One has to be negative and one has to be positive. Because you're going to do two numbers being multiplied together, the only way we can get a negative is if they're different signs. So I can already know, okay? And the positive has to be bigger. Why does the positive have to be bigger? Because we end up with a positive, right? So we know the positive has to be bigger. Okay? And so I can already say I know I'm going to have a negative number and a positive number. So we have to figure out, okay, what numbers is this going to work with? Okay? So what I'm going to do is I need to figure out factors of 140, numbers that multiply to 140. Well, Most of us probably don't have those memorized off the top of our head. That's okay. So we can go through a process. Well, 1 times 140. Does that give 140? Sure. But would that have a difference of 4? No. So let's go on to the next one. Does 2 go into it? Yes. 70 times. But that has a difference of 68. Not quite what we're looking for. We're going to have to keep going quite a bit. Okay? 3 does not go into the 140, but 4 does. And it goes in, how many times? 35 times? Yeah, that's right. Okay? So that has a difference of 31, so still point out right. 5 goes into it because it ends in a 0. And that goes into it 28 times. That's the difference of 23, so that doesn't quite work. And notice I'm just keep going up, so eventually I'll find it. 6 does not go into it. 7 does go into it 20 times. As a difference of 13, so we're getting closer. The difference is getting smaller each time. Okay. 8 does not go into it. 9 does not go into it. 10 goes into it. How many times? 14. Hey! Did we find something where the difference is 4?
Yes.
So we can stop. So the negative number is 10. The positive number is 14. The negative number is 10. The positive number is 14. Okay? So now I figured out my puzzle. So what I can do at this point, now, is I can go and I can actually split these into our factors. So I'm going to put 0 equals, just like it was 0 equals, and instead of writing x squared plus 4x minus 140, I can now use a shortcut to factor this, since our a is 1. When a is 1, we can use a shortcut. Won't be the case on number 20, but it is the case on this one, to where I can put my variable x, and then I can put this sign and number, minus 10. And that's my first parenthesis.
This is way
Okay.
too much. Like, my brain cannot focus on this problem.
Yeah, I'm really lost. You lost me with the
Yeah.
X.
Okay.
You lost me before the X. Cause I stared up into space for like 20
Let's
seconds,
see.
and I came back to like life, and I was like, oh my god. And I now know what's happening.
Well, let's try to follow along the best we can from here, and I'm going to go back through and re-explain it, okay? So thank you for communicating where you guys are at. I really appreciate that.
I'm lost.
Okay? So, then our next parenthesis is going to be the same variable, x, and this number inside, plus 14. Let's go ahead and write that down if you don't have that. Yes.
Oh
How
my
many
god.
questions?
Yeah, you're funny.
Yeah, you're
No.
I know.
See, you always think it's going good, and then you get to the last, and you're like, okay, we're switching everything up. And I'm like, because it always just starts off easy, and you're like, okay, I got this. You can do this. And then, bam, it goes to this, and you're like, I don't know what's going on.
What a challenge it is, too.
What is that?
So it's just a method we can use to factor. So for actual factoring, there's methods that do and don't include this. I prefer this method because I figured out for my students, typically in the way I teach it, this ends up getting communicated easier, and it creates an organizational method that students end up typically liking more than other methods to try and factor, from what I found. So it's just a method that we use to help us factor, to help us find our factors.
Well,
Okay. Not everyone likes it, that's okay. But there's other methods too, but this is the one I teach because I found it to be
are you going to
Um,
teach us the other
the best to
methods?
teach, okay?
We
um,
don't like understand.
we don't have the time today to do that, so no. Okay. So now, what we can do here is if we were to multiply these back together like we did here, we would get what we just had. We'd get x squared plus 4x minus 140. We'd get that. So just like here when we got x squared plus 4x minus 5, when we multiply these together and simplified, if we multiply these together and simplified, we'd get back to here because they're mathematically the same thing. Now, what happens when you multiply two numbers to get to 0? What does one of the numbers have to be?
0.
0. You can't multiply two numbers and get 0 unless one of them is 0, or both of them are 0. Let's try seriously, think of a way that you can multiply to get 0 that doesn't include 0.
Say it again.
Think of a way to multiply to get 0 that doesn't include 0. You can't. Everything includes 0. At least one of the numbers has to be 0. They can both be 0.
A 0 could be in this.
But 40 times 2 is 80. But to get actually 0,
What about a negative?
one of them has to be 0. Negative 2 times positive 4, negative 8. Yeah, so negative would just change the sign. So that means
Isn't there
that-
something like weird, like 1 times or something?
so that means that one of these has to be 0, because these two things, this first parenthesis is multiplying with the second parenthesis. That means at least one of them has to be 0. According to that rule, that in order to get 0, one of them has to be 0. One of these has to be 0. So if this has to be 0 or this has to be 0, we can take x minus 10 and say it is or equals 0. Then we can take x plus 14 and say it is or equals 0. We can say it is or equals 0.
Okay, wait, I've lost time.
These
Okay.
are.
So we take this first parenthesis and set it equal to 0, because we said, hey, for this to work, this or this has to end up equaling 0. So we set it equal to 0. Now we've solved these one-step equations. This is the part of the factor we like, because a one-step equation, okay, I add 10, and x is equal to 10. Or I can subtract 14, and x is equal to negative 14. So we end up getting two answers here. We end up getting two answers here because we end up having an exponent of 2. We end up getting two answers because we had an exponent of 2. Okay. I can do it faster, but I don't know about less steps. Okay. So I'm gonna recap what happened.
Recap time.
Okay. So yep, recap time. Okay.
Braden is gonna come back and be like, what in the heck?
Okay.
No,
So,
he doesn't know.
Dark blue we started with was
Yeah.
cross. Guys, cross multiplying is what we started with. We've been doing cross multiplying. In this case, we just set ourselves up to where we had to foil. Kel told us that was called foiling. We had to foil this. Okay, I think that was you. Yeah, okay. And so we multiply the first, the outsides, the insides, the last. Everything in the first gets multiplied with everything in the second. Then we simplified. Negative x plus 5 gets to be simplified. You saw that math? Oh, we can do that. Then we said, okay, in order for this to work later, because we need it to be equal to 0 for this step to work in the light blue, we had to make it equal to 0 here. So subtract 135 and make it equal to 0. Then what I did was I set up this x, and I fill in the top of a times c and the bottom of b. If you didn't write this x and the a times c and the b, go ahead and do that now. If you didn't write this part right here, do that now, including the a times c and the b, okay? You seriously need that, okay? Otherwise, you're probably going to forget what goes where.
I remember this.
Okay. Okay? So then we put whatever the a times the c was. So in this case, ax squared plus bx plus c, we said a was 1 and c was negative 140. So it's negative 140 because they're multiplied. And then b was the 4. And we said, okay, well, how can we multiply to get this number, add to get this number? And we said, okay, well, it has to be a negative and a positive. And we went through and we found out the two factors of 140 that had a difference of 4. Then we were able to do this variable x, the number and sign, negative 10.
You left us a lot of room.
You're welcome.
Yeah.
Yeah.
That was sarcastic.
Yeah, my ear was sarcastic too.
Good.
Okay. And then we did the same variable x in this number and sign plus 14. Then we said, okay, well, one of them has to equal 0 in order for this to equal 0. If I were to go back in and I plug in 10 right into here, I get 10 minus 10, so that equals 0, doesn't it? And what's 0 times anything else? 0, so it works out. If I plug in negative 14 plus 14 is 0, and that equals 0, because 0 times anything else is 0. Okay? We're actually going to skip number 20. We're going to skip number 20. Okay?
Well, we had a problem.
Okay. We're going to skip the problem like number 20 on the homework too. Yeah. Actually, I think that's right.
Do you want?
I
Me
love
too.
it.
What's the rest?
It's my favorite.
My favorite.
Actually,
I know so good.
Actually.
Yeah,
see if I won. Are they doing that right now?
I don't know if they're gonna do that.
Well, they didn't do it.
We might do it at the end of lunch.
You have to do the whole thing.
Okay.
So-
But what, there's a don't do of 22. There's a don't do of 22. 22, guys, 22 is like the one that we skipped. 21 is like number 19 in our notes. 21 is the only one like number 19 in our notes. Okay? 21 is the only one like 19 in our notes.
Okay, so don't do it and then everybody asks for it next time. Yeah.
Like I don't already know
Don't
that.
do it. Yeah. Somebody else said it.
Hey Wyatt, you're right, it's 8 -4.5.
My ribs hurt so bad. I need to go get adjusted before this weekend.